Alright, so we're back again with the 2014 AMC 12B. Right over here we've got this problem indicating we have a square of side length 1 and the rectangles JKHG and EBCF are congruent, and we need to find BE. So this problem looks very easy because it's just a rectangle and a square. How hard could it be? But don't be fooled, it's a lot harder than it looks like, and it's definitely well deserved a problem 21 or to 25 on the 12B, and it took me like a very long time, like a day, to actually figure out how to do this. So yeah, so I kind of already made a sketch right here, and we're just going to try and work with this sketch right over here. So it gives us very little information. It's just these two rectangles are congruent, this one's tilted, and it's a square of side length 1. So pretty simple information so far, except we're going to need to create a lot of triangles in order to help us find what BE is. So what we want to do is we want to assign variables. So first we're going to let this equal x, let BE equal to x, and let the distance from D to G equal to y. So I'm going to try and erase this. And then this D. So let this be y. And then we can just try and mark up the rest of it. This is obviously going to be the same, and these two triangles are pretty blatant to be equal, because you can pretty much tell by symmetry that those two triangles are congruent. So we can mark KE equal to y. Except the problem is we do not know what these lengths are. Now you might be tempted to use similar triangles, but realizing after working through a ton, you get very ugly expressions, and you're pretty much unable to use similar triangles for let's say you'd be unable to use similar triangles for these two triangles, and because the expression you'll get would pretty much be unsolvable in the time limit you have in the AMC. So what we're going to actually do is we're going to create diagonals after we create this, and maybe fill in some more lengths. So we know that this length is going to, EK is going to equal to 1 minus y, marking it up because this side length is going to be equal to 1. So obviously y minus 1 plus y will equal 1. And we can do the same thing for GA. Call this 1 minus y. Alright. So now we're going to create some new triangles that will help us. So now we can create this diagonal length right here. And that could help us a lot. And we're going to also try and create a diagonal length right here. Now these are kind of arbitrary, but you might think that these are very arbitrary lengths to choose, but your goal is to just create as many altitudes or diagonals or any sort of thing that would help you find whatever EA is equal to. Because if you find EA in terms of x, if you find EA in terms of x or FD in terms of x, then you pretty much solve the problem. So our real goal is to find EA in terms of x, because if you find EA in terms of x, then you just have x plus EA equals 1, and then you can easily just solve for it, and obviously this is just equal to BE. And then if you solve for x, then that's pretty much your answer. So we're probably gonna circle this. That's our goal. And our first step is to find the length HD, and we're going to be able to do this by creating these diagonals. So now, because we are given that these two rectangles are congruent, we can make kj equal to x and hg equal to x. And we can let hk equal to 1. So now, given these constraints, we know that the diagonal hj, we're going to try and erase this because I just proved why we need to find that goal. This is going to be our scratch pad right here. So right over here, we know that kg is equal to hj. And then by Pythagorean Theorem, we know that that's equal to square root of x squared plus 1. Because we know this because we have hg squared plus hk squared equals kg squared. So that means 1 plus x squared equals kg squared. And then obviously kg equals square root of x squared plus 1. So that's kind of a proof right here. So that's step 1. Now we have a little bit of more information, so we can try and mark this as square root of x squared plus 1. It's kind of hard drawing with the mouse, but it's the best I could do right here. And so now we're going to try and create some triangles. I was going to say triagonal, but we're going to try and create some triangles, and that should hopefully help us out. So we're going to just remove some of this to help us out, clean up some space. So now two ideal triangles would be creating this triangle because it contains the new diagonal length that we have, and then another diagonal that could help is this one right here, and create another altitude right here. And it may be hard to see which ones it is, but I'll try and outline the triangles that we want. So we don't want that, actually. I'm just gonna do that. So this looks like a very ugly, oh man, I don't know why it's doing that, but right, so now we place that. So now we're gonna mark up the triangles we're gonna need. So we're gonna need this one. I'm gonna mark that in yellow. And then we're gonna use this triangle right here. Mark that in yellow. So you might wonder, why would we need to know these triangles? First of all, we know very easily that this length right here is, we already know the diagonal lengths. And since we found the diagonal length, which is just square root of x squared plus 1, it should be very easy to find x in terms of y. And then from there, you could find EA using this first triangle we created. And it's really just all of a matter of dropping altitudes and creating more triangles and finding congruent triangles and whatnot. And that just helps out a lot. So after you do that, we're going to try and find the lengths of these triangles. So now what we have from these highlighted triangles we have right over here, let's call this length M, let's call this N. So now we have MK equal to 1 minus 2y, because we mark this is a rectangle and this is y. We have mg equal to 1 minus x, and we have gk from our thing right over here, derived at top is equal to square root of x squared plus 1. So that's the first triangle. Now we're going to separate this into another for the other triangle. So now we have hn is equal to 1. We have jn equal to, this is kind of a question mark so far, but finding jn will greatly help us find this length. And then finally, we have hj equal to square root of x squared plus 1. So now we can use the Pythagorean Theorem once again to help us find that in terms of y and help us find jn. So now what we can do is we have, by Pythagorean theorem, we have 1 minus 2y squared plus 1 minus x squared equals to x squared plus 1. Note that this thing squared will easily cancel out with x squared plus 1, which is very helpful, and you have to kind of foresee that. Expanding these terms, we get this. Now we can simplify that even further. So we have 2x equal to 4y squared minus 4y plus 1. This is pretty much as simple as we can get so far with this equation right here. So now we have another equation involving the x squared plus 1 with this triangle right over here. So now we're going to try and find jn in terms of x, and that could help us out quite a bit. So we know that jn squared plus 1 squared is equal to x squared plus 1. So jn is just equal to x. So right over here we have jn equal to x. Now this will be very, very important into finding the bottom length. So this information with jn equal to x is extremely crucial, and you would have never thought that this base right here would equal to x, but that would be a very crucial piece of evidence to finding it. So now what do we do next? So we know that EJ is equal to length HD. And why is that? Because before we proved that these two triangles are congruent, so these two lengths are congruent because the triangles are congruent. So because HD and EJ are congruent, we have EJ equal to NA at the bottom. So now we have this is congruent to EJ and HD. So what does that tell us? That means we can say that means we can now create an expression for whatever EJ is in terms of x, and that is our goal right over here, find EA in terms of x. So now we have 2x plus EJ plus NA is equal to 1, and that means that 2x plus 2EJ is equal to 1, and that means EJ is equal to 1/2 minus x. We're going to circle that right over here. So that will be very important. And now we pretty much solved most of the hard part right over here. So now, at last, what we can do is use the Pythagorean Theorem on triangle EJK and help us find y in terms of x. So now I'm going to try and fit this over here actually. So we have x squared is equal to y squared plus EJ squared. So now we have x squared is equal to y squared plus 1/2 minus x squared. Now we have x squared is, and you can tell that the x squared will cancel, so we have no ugly quadratic, is equal to 1/4 minus x plus x squared. Now these simplifying even further, you get y is equal to x, or y squared is equal to x minus 1/4. And then now we can finally use this equation right over here, and solve for x. And we will get a relatively easy expression to solve because all it is I don't know where my, alright, here it is. So because it will be a relatively easy expression to solve, because it will just have one square root, and that will be pretty easy to solve. So now we can let y equal the square root of x minus 1/4. And then now we're going to bring this down right over here. So now we have 2x is equal to 4. Giving that equation, we write over here 4 times x minus 1/4 minus 4 square root x minus 1/4 plus 1. Now, I really have no space, so I'm going to try and just fit all this. It should be very straightforward on how to simplify this. So we have simplifying this enough, you should get 2x you should get 2x, negative 2x, or you should get x over 2 is equal to square root of x minus 1/4. That's if you simplify it enough, and simplifying it is very simple and easy. And now we square both sides, so we get x squared over 4 equals x minus 1/4. Now we're going to bring this down again. Kind of hate fitting it down here, but now we have x squared minus 4x plus 1 equals 0. And then now it's just using the quadratic formula, and that would pretty much be it. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2, which is equal to 2 plus or minus 2 root 3 over 2. Oh man, I hate this. Right over here. And then we have 2 plus or minus square root 3 is equal to x. So now, if we look at the answers right over here, the only answer that includes it is 2 minus square root 3, and also 2 plus square root 3 would be greater than 0. So we now must know that x is equal to 2 minus square root 3, and therefore C is your answer for problem 21.